this need for recycling, it's making it cost effective again. So just a little fun fact of the day, in case of paper, recycling saves trees and water, making a ton of paper from recycled paper saves up to 17 trees and uses 50% less water. So we have a number of presentations today. We have sections for Q&A, so bring your A game, ask tough questions, ask things you want to know. We are having prizes drawn for students. So if you register, we'll put your name in a bag. We'll be drawing that throughout the day. And please view the posters. There's 23 posters out there, and when you vote, please go and look at them and make some good conversation. We're gonna have a voting for the best poster, and they win an extra $100. So make sure to vote. Only one vote per person, please. Bathrooms are down the hallway. They're actually right here. The bathrooms are over here. We're in the Sonata. If you have any questions, come talk to me. If there's an emergency, please exit through the stairwell. And lunch and all the breaks will be in the room next to us. And finally, this wouldn't be possible without our awesome sponsors, BP, uw-madison Office of Sustainability, ATC, School Choices, WPUI, Exelon, WEI, We Can Serve, and XL Energy. So we greatly appreciate the sponsorship they've given us. There's a couple sponsors today, so make sure to talk to them. They'll be in the tables out here, and it's going to be a great day. Okay, now to introduce our speakers. So we have Waste Management talking about the big picture of waste and then some landfill gas. So we have Tim Gray. Tim is a Waste Management Strategic Business Director for Healthcare and Higher Education for the Midwest or in the United States. He brings 19 years of business experience in healthcare and environmental and education markets in North America and Europe. Tim has a background in developing new partnerships with large partners which have complex decision-making processes involving universities and state governments. At Waste Management, his focus is on partnerships to manage environmental risks and deliver sustainable outcomes. And then we also have Dan LeClaire. Dan is an environmental engineer with Waste Management. He graduated from this lovely university with a degree in civil and environmental engineering, and he's been with Waste Management for 25 years. So let's give them a round of applause.
Well, good morning, everybody. Thank you for inviting me. I'm going to talk a little bit about the modern history of waste, the waste industry, how it works in the United States, and then we're going to have a little more detailed presentation about a specific technology that's widely used, particularly by my company, to extract energy from solid waste. So the modern era of waste management began with the Industrial Revolution, and not so much the scientific understanding that leaving garbage lying around was probably not a very good idea, and that it was connected to disease, but the political understanding in the middle of the 19th century that government had to do something about it. And it really began primarily in the United Kingdom and quickly spread to the United States. So this lovely Victorian gentleman wrote a very famous report, which is frequently cited, for example, in Dickens, and it's often seen as the foundation of the modern solid waste industry. The realization that as a society we had to do something about trash. And it began in ways you might expect. Horse and carts went around, collected trash, and really we used to do three things with trash, and they're similar to what we do today. We either threw them in a hole in the ground, we burnt them, or we fed it to animals. And as you can imagine, in the Industrial Revolution, there was little regulation, so there were thousands and thousands of landfills, holes in the ground, and incinerators. You could do pretty much what you like. Not sure if I can get this to play. What we would be seeing here is a movie clip from around the turn of the last century, which shows how waste was processed in New York City. And basically, there was a remarkable amount of recycling back then, more than today, because the materials were considered to be so valuable. Before anything was burnt, in this case, in New York, everything of any value was extracted by human labor. With the advent of the motor car, we saw our first trash trucks. One of the most common things to do 110 years ago was to reclaim land from the sea or from rivers using trash. So you'll be familiar with the term landfill. A lot of the original landfilling was literally trying to create new land from trash, and of course that put all sorts of things we wouldn't want to see in our water supply. But by 1910, but just before the First World War, almost everywhere in the United States had some kind of organized system of taking trash away from people's homes. It was widely understood that feeding trash to animals was probably not a good idea, but it really wasn't until the 1950s when we started to regulate it. And that was typically done at a city or county level, with governments saying humans cannot consume meat if the animals have been fed with trash. But the real key year in the modern waste industry was 1970, and a bunch of things happened then. The Clean Air Act was signed, and that meant that the old-fashioned just burning trash was no longer viable. The RRA started to seriously regulate at a federal level what happened in landfills and waste disposal. Earth Day was first celebrated, and the EPA was created, and that's the primary regulator for our industry still today. Recycling really got underway, or the modern type of recycling in the 1970s. We had the first bottle bill, where you paid a deposit when you bought something in a bottle or a soda can, and you got paid when you returned it. Curbside recycling, where a truck comes to your home and collects recycling, began in my hometown, actually, in Missouri. And RCRA in 1976. RCRA is the primary piece of legislation which still regulates what we do in the solid waste industry today. Trash trucks, as you imagine, have changed rather dramatically. This is a modern waste management truck. A modern trash truck can cost up to $500,000 to put in the road. And most of our new fleet, we're the third largest private fleet in the country, so there's a lot of trucks out there. Most of our new fleet runs on compressed natural gas, and much of that we capture from our landfills, from our solid waste. So we're going to hear a little bit more about how we do that in the future. By doing that, there's a significant carbon footprint reduction. Our trucks also use GPS, all sorts of modern technology, to make their routing more efficient. And we can actually see as much greenhouse gas reduction from good route optimization and that kind of technology is from changing what we burn to drive those trucks. And we are experimenting with hybrid trucks, which is probably something we'll see in the next decade or so. So my company was one of the pioneers of single-stream recycling, and single-stream recycling, where you don't have to sort, has been transformative in terms of increasing the recycling rate, but it's still kind of disappointing. So in 1960, 6.4% of our trash was recycled. Today it's about a third. that I do in my role, I go to a lot of university waste audits as an example. And typically what we find is even after recycling, what's being sent to the landfill from a university is about 80% recyclable. So almost everything we throw out doesn't need to go into a landfill, although most of it does. And my company recycles about 14 million tons of solid waste, and we'd like to do more. We'd like to keep more out of our landfills and find a better use for it than throwing it in the hole. So one of the things we do today to extract energy from waste is, remember we talked about originally, we used to burn trash? Well, we still do in a much better way. So we have a number of incinerators, waste to energy plants. Most of them were built in the 1970s. But that's a much cleaner way of burning trash and extracting energy than it used to be. We'll talk about our landfill gas capture program in a minute. And then we're investing in some new technologies. Some of it basically involves taking unrecyclable plastic or organic waste and turning it into a fuel source, which would be burnt in a power station alongside coal. And the other thing we're doing is we've got a number of plants we've invested in, really at the pilot stage, where we will produce biobutanol or bioethanol, so we can power cars or planes using components of organic trash treated with enzymes. So that's something we see in the future. Those are really at pilot stages. My company's approach has been to invest in lots of different technologies at pilot stage to see which works. But our goal as a company is to try and extract more value from the waste that our customers throw away than we do today. And much of that's about capturing the energy in that trash. So with that, I'd like to hand over to my colleague who's going to talk a little bit more about how we do that today in the process of landfill gas capture.
Environmental engineer. I come from the Great Badger State and the Badger University here. I'm going to talk a little bit about what happens after trash goes to your curb. Everybody generates a little bit of trash. It just depends on what we end up doing with it. As we talked about earlier, there's a lot of different options. I'm going to talk primarily about landfilling. You take garbage and you put it in a landfill and it decomposes and you're generating gas. The gas is a problem in that it's explosive. If you don't manage it, you can blow people's houses up, which happened years ago in Madison. There was one. So what is landfill gas? As the garbage decomposes, it generates approximately 50 to 55% methane and 45% carbon dioxide, along with some trace VOCs and some nitrogen. It's a renewable energy source in that we're always generating garbage. Basically, landfills are a large biological treatment system. It's kind of like the digesters, but basically on a much, much larger scale. Because basically you've got a huge liner, you fill it with trash. You're basically using microbes to feed on the waste. It's an anaerobic process, and that you have to carefully monitor it. Any oxygen in the process will actually kill off your microbes and stop the gas production. How do we know how much gas is generated? There's a lot of different models that you have to use and look at. Basically, it all comes down to is how many tons per year are you putting into the landfill, which basically is your supply of food. You look at the type of waste. Organic wastes produce more gas than, say, plastics, which don't produce any waste. You look at your potential methane generation, really, which is the amount of fuel, which tells you how high your curve spikes. You look at your methane potential, which is basically the amount of food, that they can work, which is basically the area under the curve. And there are certain things that you can do to generate more gas or to generate less gas. One thing that we've been doing a lot as a company, and specifically in Wisconsin, is turning our landfills into bioreactors, where you're basically adding liquids. We're adding leachate, which is a liquid that comes out of the bottom of the landfill, and reintroducing it. We're also taking like third-party liquids that have a hard time getting rid of, like treatment plants won't take them. We're putting them in the landfill. And what that does is by getting more moisture into it, you've actually created an environment that's more suited for the bacteria. On the other hand, if you have a dry landfill, like prior to the last 10 years, they used to be called dry tomb landfills, as in the whole idea was to keep the moisture out. By keeping the moisture out, you really kept the microbes from eating on the trash and producing gas. And you basically entombed it forever. The new philosophy is to react to garbage right away so that you eat up the organic content sooner, so the landfill stabilizes, so you're not leaving it for future generations. One thing to keep in mind is if you start removing organic materials such as yard waste, food waste, and paper waste, you actually will reduce the amount of methane that can be reduced because you're cutting the fuels or the food sources out. So here's kind of a curve to show you how landfill gas is estimated. Where basically the height of the curve is basically the rate of generation. The wetter landfills, that curve is higher. And the area under the curve is the amount of food in the system. So if you've pulled out the organics, you've got less area under the curve. So here's a curve that shows you the red is the normal case. Blue is you remove yard waste. Purple is you remove basically half of the paper through recycling. The yellow is you remove 90% of yard waste and 50% of food waste. And the bottom line is you remove all the yard waste and food waste. So basically, as you start pulling organics out of the landfill, you basically reduce the amount of gas that can be collected and used for energy generation. Now, how do we get all this gas? You've got this big landfill full of trash. It takes a very complex system to collect all this gas and get it to a system. You have a series of wells, wellheads, which is what connects the well to your piping system. You have miles and miles of pipe of large diameter headers with smaller laterals connecting all the wells. You have a condensate management system. Landfill gas comes out 100% saturated. You have to reduce it to a dry gas, so you have to remove all that moisture. And you need a vacuum source to get it out of the landfill into a spot where you can burn it and use it. So there's either different types of blowers or compressors used to put a vacuum on the hill. And then you have to deal with the gas. You can either flare it, which is what used to be done, or you can use energy recovery. Right here is a typical drill rig that's used for drilling in a landfill. It's got a Kelly bar, as in that drill stem actually extends approximately 200 feet, so there's drill stems stacked inside each other, kind of like the little Russian dolls. It's got a 36-inch diameter bucket. There's basically a bunch of different buckets they have to use. A lot of this stuff was developed as part of just soil retention types of projects and pilotings, and they've kind of modified them for use in the landfills. As you can see, when the garbage comes out, it doesn't look like the trash you put at your curb anymore. As it decomposes, the organic material disappears, and it kind of turns into more of a soil type material. Right here is just a well going in. It's a Schedule 8 PVC pipe, perforated. And then it's got a gravel pack around it, large enough that the gas can make it to the well. As you can see, they start producing gas pretty much, once we've got them drilled. We typically drill them within about 2 years of putting waste into the landfill. So as soon as it's producing recoverable quality of gas, we start collecting it. This here is a wellhead that's used to connect the well to the header system. This kind of shows you how the landfill cover system would be. Everything is booted up. It's like the safe sex of landfills. Everything is completely sealed. So when you close the landfill, there's no air getting in, there's no water getting in. The wellheads, basically you have to monitor oxygen because obviously oxygen kills your methane bacteria. You're looking at the methane content. Balanced gas, if you're pulling nitrogen, it means you're pulling air, that means you've got leaks in the system. You look at the amount of vacuum, and you look at your available vacuum to make sure that you don't have any problems in your system. And this is an ongoing process. You have to keep tuning these wells over and over and over and over, because it's a dynamic system. And the minute you tune one well, you've changed every other well in the system. So it requires a lot of manpower to properly balance these systems. Right here is some of the piping system going in. In a landfill, it's typically all high-density polyethylene pipe, which is the same as milk bottles, although they add carbon black. That's why it gets this black color, so it's UV resistant. It's a flexible pipe, as in as the landfill settles, it will not break, which is why it's used in this system. It's all welded. That's a butt fuse welder right there. Basically, you weld your joints, so it's a very high-pressure, well-sealed system. That's just another picture there. And I mentioned about having to remove the condensate. Basically, you use vessels that basically use different mechanisms to remove the liquid out, drain it out. You have it within the system, and then before you use it, you have to remove the liquid again. And this is just a real basic fan blower here, to put the vacuum on. Which here's a more complex system here, where this is a utility flare, where the gas can be burned off. But we're here to talk about energy today. Believe it or not, it was in Wisconsin that Waste Management first started doing energy recovery. We have two sister facilities in the Milwaukee area, where we put in energy recovery in 1985, which is the very first landfill gas electricity facilities that Waste Management produced. Now we're up to 160 facilities, producing 700 megawatts of power, which is about enough for 500,000 homes. So we've gone a long way from those first two plants to what we've got right now. When you're looking at landfill gas, you can generate electricity, which really is the easiest and highest value that we find for the gas. You can either use turbines, which are similar to aircraft engines, or reciprocating engines, which is similar to your car engine. Granted, these are all specialized and then modified to run on landfill gas. It's a dirty gas, so it's a very corrosive gas, so you have to have specialized engines. You can't just pull one off the shelf and it'll burn it. Other uses, you have medium BTO gas. As I mentioned, landfill gas is approximately 50% methane. So in its pure form, it really is only half the gas, only half the energy content of, say, compressed natural gas or natural gas that you use in your homes. There's uses where you can send it to a boiler if there's somebody nearby. We have one where we send it to a rendering plant. High BTO gas is basically where you get it to 100% methane, which requires a lot of refining, a lot of processing, and it's basically pipeline quality. And then you can actually put it back into a natural gas pipeline. Because of all the engineering logistics with that, it's not your preferred method. And some of the newer stuff being done is basically taking landfill gas and converting it to fuels. You have liquid compressed natural gas and you have diesel. Again, you can run into the issues with having to purify that gas for those uses. This is just a picture of a compressor station used for selling gas for a medium BTU site. And here's a picture of one of the solar turbines, which is from one of our facilities in Milwaukee. We actually run 5 turbines like this in the Milwaukee area. Each of these is a 3.2 megawatt turbine. The downside of the turbines is they take a fair amount of parasitic energy to run, and that you have to compress the gas to very high pressures in order to burn it. Which is why, because of the issues with the turbines, a lot of our new facilities are reciprocating engine plants. Here's one right now. This is just down the street from here in Watertown, Wisconsin, right by the Johnson Street outlet malls. It's an 8-engine facility. It's 6.4 megawatts. Each engine is an 800 kW engine. The beauty of engine plants is they're very flexible, as your gas curve ramps up and down, you can add and remove engines. Here's kind of just a quick schematic. You get your landfill, you basically use your compressor to extract the vacuum, you get it into the engines run a generator, goes from a switch gear to a transformer to your home. Right here is just a picture of a compressor. The way the compressors work is as I mentioned, it's a dirty gas. You have to come in and you first filter it to remove particulates, liquid. You compress the gas. It's part of the compression process. It actually is generating heat. The gas then has to be cooled, filtered again, and then you can deliver it to your engines in around 3 to 12 psi. And this is just a picture of an aftercooler. It's basically like a little radiator outside to remove the heat. And this here is a picture of our engine bay here. This is, like I mentioned, the 8-engine facility. Gas manifolds on top, basically feeds each engine. As you can see on the right side of the engine is the generator. The generator produces at, depending on your utility, at different voltages. There's a lot of different ways you can generate electricity, but typically it's generated at 1 voltage and it has to be changed to different voltage. These are the radiators for the engines, a little bit bigger than the one you see in your car, but the same concept. And this is basically what runs these things. This is basically the switch gear, which is how you basically phase your energy to go to the power company, along with all the other motors and fans to run these plants. It uses a huge amount of combustion air, so it basically got fans almost like aircraft engines, and they're providing enough air to run one of these plants. As I mentioned, the different voltages, you have to take your electricity at lower voltage and bump it up to transmission voltages. It's much more efficient to transmit energy at higher voltages, so once it goes to the power company, it's got to be bumped up in voltage. And then a lot of times utility will bump it one more time again for their super high voltage transmission lines. And then as you burn all this landfill gas, there's a huge amount of heat generated. As you saw those giant radiators there. What about all this waste heat? Is there something we can do with this heat? Well, if you have a gas plant that's in close proximity to a user, like a maintenance facility, an office, or a greenhouse, you can actually harness that jacket water heat and use that energy as well. Typically, it's like a shell and tube heat exchanger. You take that heat from the radiators before it goes to the radiators, run it in a pipeline, and you can either use hot water heat systems, as long as you have mixing valves so you don't blow up your concrete. You can have downdraft units, which is like a radiator, or you could run different type systems in these greenhouses. So there's a lot of different uses you can do in the landfill gas. So it's, when you think about that trash, I guess you got to think that there's actually value from an energy source in that trash, because you're generating it every day. There's a never-ending supply of our energy. So, does anybody have any questions? Sure.
I was just curious, what's the density of wells in landfill? Like, we have a 170, 100 meters.
The radius of influence, we typically look at around the 250-foot radius of influence. As the landfill gets wetter, you got to tighten that radius. Sometimes we've gone as tight as 75 foot. So basically, you draw a circle every 150 feet, and that's about how many wells you would have for a wetter well. Sure.
Do you guys control the bacteria content or engineer the bacteria?
No.
The oxygen and things like that?
Basically, the bacteria is naturally occurring in it. What we do control is the amount of liquid in it as we add liquid back in to basically produce it. And the other thing is you got to basically seal it off really tight. So basically, you have to put plastic seals along your gravel, soil seals around it. And then the other thing is we have to make sure when we tune our wells, if you pull too hard on a well, you pull air in, which has oxygen and it'll kill it. So we have to control it so that we don't add that bacteria ourselves. Yeah.
Can you give us a feel for the size of a typical landfill that you guys manage?
The one I showed you for this gas plant, that landfill is like 117 acres.
And how deep is it?
It really depends on the water table. I've got some that are 200 foot deep, and I've got some that are like 120 foot deep. Depends on the state you're in. Like in Wisconsin, they've got some regulations. They're not as big as they are in pretty much every other state. You get into some of these states, and they can be, you know, hundreds and hundreds of acres and quite a bit deeper. But the real limitation is your drill rig too. The drill rigs only go like 200, 220 feet. So you can't go too much deeper than that. Yeah.
How do you monitor the composition of the landfill gas? You talk about nitrogen being present, and that's a sign of pulling in air. How do you know there's nitrogen in there?
Okay, we have a couple different mechanisms. We have a handheld mechanism which basically measures the gas, you know, using, you know, real-time measurement. It's not as accurate, but that's basically we go out from well to well and measure it. It'll measure the nitrogen. It actually doesn't measure nitrogen. It measures methane, oxygen, and CO2. And then they call it the nitrogen balance gas, because basically anything left has got to be the nitrogen. If you want to measure the nitrogen in our plants, we actually have gas chromatographs, which can actually measure the nitrogen, but there is no field type measurement that does nitrogen directly. So between those two instruments, we can, you know, measure these. So at the plant, the gas chromatograph pulls a sample continuously, so we're constantly monitoring the quality at the plant. We're also looking at the vacuum. If the vacuum goes up or down, it checks the quality. So there's a lot of little balances to, you know, keep it going.
What is the productive lifespan of a typical well?
What is the predictive length of a well? It really depends on how much moisture you've added in a well. As we talked about turning these into bioreactors, by doing that, you've, you know, increased your gas generation, which also means you've increased your decomposition of the waste. So if you get waste wet enough, you can have it basically cooked out in 2 years versus the old dry tomb site. These wells will last 20 years. So it really depends on how fast the process is working. If the process was working faster, the wells don't last as long. You can kind of regulate it by your, you know, by your inputs. Yeah.
So after a well is done producing, what happens with that land? Is more waste added, or what do you use it for, I guess?
What do we use the landfill when we're done? The way landfills work is it's kind of like building a pyramid. So you have to kind of start low and work your way up high. We put in a lot of temporary wells, as in, you know, the federal regulation says that within 5 years of putting that first piece of waste in there, you have to have an operating well. We normally go about 2 years because otherwise it starts to have odors. So you put in a lot of temporary wells, you extend them as you go, and then you have to just keep re-drilling them. As for the area where the land is, we have like a design overfill. In other words, if your landfill is going to take 100 feet of waste, they'll put in 110 feet of waste, basically assuming it's going to settle. You know, that's all the DNR will give us. In reality, we probably need more than that. It's settling probably closer to the 25% range. But you try to build it higher than it needs to be, knowing that it's going to settle back down. But like for land use, most of them are just natural open areas when you're done. You know, you'll never be able to build on them. It's not stable, and then you got to maintain the cover systems.
We have some with golf courses.
We have some with golf courses, but that's kind of the exception. That's really more of the old landfills that were flat. Most of our newer landfills are too steep to be golf courses. Any other questions? Sure.
I kind of have a general question, not technical. So you said that you do sustainable activities, like save the energy, but you also making profit with processing the trash. So how do you balance this contradiction, and how do you educate people to trash less, to waste less?
Well, it comes down to our company. Basically, we're the world's largest recycler. So basically, we work in every aspect of the solid waste industry. We do composting, we do processing, we do recycling. So, you know, we've set it up to, you know, we'll manage whatever wastes come in whatever form.
And do you have some programs to educate people to kind of save waste and energy?
Should I talk about that?
Yeah, you can talk about that. I don't deal with the education side. I'm just the technical guy.
Thank you. So what my company is trying to do is invest in technologies to extract more value out of the waste streams. so that throwing it in a landfill is the least profitable thing that we could do. But in the meantime, we are America's largest recycler. We generate more renewable energy than, for example, the entire solar industry. Just our company, by doing what we were looking at, recovers more energy than the entire solar industry. So we're doing quite a bit today. But yes, we work with, particularly in the education space, actually, that's one of our major areas, K-12 and universities. We work with our customers to try and keep as much waste out of the landfill as possible. And we have a number of, like, you'll have maybe seen some car companies advertising about having zero waste plants. That's typically by partnering with us. And we have a couple of universities in Canada we work with who want to become North America's first zero waste institutions. So we do a lot of that. But the long-term strategic goal is to try and find technologies to make more money out of doing something else with what people choose to throw out than throwing it in a landfill. That's what we're trying to get to.
Yes.
With natural gas so cheap, do you guys just mainly burn out the biogas you get and then buy natural gas to power the fleet, or do you highly scrub what you get out of the landfill?
We do a little bit of both. Most of the natural gas we use for the fleet is just off the pipeline. Just because there is engineering logistics of using landfill gas for CNG. As I mentioned, any air in the system adds nitrogen into the system. Nitrogen is an inert gas and basically has no BTU value. So the landfill gas that you convert it to CNG has less power than pipeline quality gas would have. So most of it that we use in the fleet is pipeline quality. We do have a couple of facilities where we have high BTU facilities. We have one, I believe, down in your neck of the woods by St. Louis.
And one in San Francisco.
Yeah, where we're actually taking the gas, converting it to pipeline quality gas. We actually have an agreement where we put it in the pipeline and we quote, it's kind of like electricity. You put it in the pipeline and you pull it out somewhere else and you call it your own gas. Same thing with electricity. When you're buying green energy, we put it in the pipeline, but in the wire, nobody knows what comes out the other end. It all gets mixed together. Same thing with the natural gas. So we do have supply where we're putting it into the system, but most of it's just pipeline quality coming out. I see later today there's a talk where Dane County will talk, where they've got a small system where they're using CNG, where they're directly getting it off the landfill. From my standpoint, you almost have to do cherry wells to do that, as in keep the methane quality high so that you have raised low nitrogen levels. To do the entire landfill and turn it into CNG is really not practical, because then you're going to have odors. We like to pull as hard as we can on the landfill, which gets your methane quality lower, but it also makes sure that you don't have any odors. You can smell a landfill, chances are you aren't pulling hard enough and you're letting gas escape. So that's kind of why the CNG is not high on the priority list. Electricity is basically our bread and butter where most of the energy goes. Yes?
One of the side effects of burning the methane off landfills would be that you're taking carbon from those ones, propylene, and moving inside, and you're converting the carbon dioxide down the atmosphere. So almost all energy companies have some kind of carbon dioxide sequestration policy. So how does, and especially the carbon tax probably coming up, do you guys have any ideas about that?
Well, the thing you remember is, when you look at a carbon sink, a landfill is the largest carbon sink there is. In other words, you're actually taking more carbon out of society and putting it in the landfill than we're emitting. So we're actually, our net balance on carbon is a win. And the thing of it is with the methane, if we didn't collect it, the methane would go straight to the environment, which has a much higher value, on the carbon than, say, the CO2 would on there. So by generating the landfill gas, we've actually, reduced their carbon. And then the landfill, like itself, is a big carbon sink, as in, we're not getting all the carbon, for every pound of trash you put in, we're not burning every ounce of carbon. There's a fair amount of it that just stays, consumed in the landfill. Yes?
So you talked about how valuable food waste and yard waste are as components to this system. So what does that mean for businesses and institutions, or even cities that are starting to curbside compost programs? They're removing that part of the system? Is that an impact that you felt at any of your locations?
Yeah, Yeah, as in, we're seeing our gas generation curves drop over time as, as more waste are being diverted. You're pulling your organics out, you're pulling your paper out. It's, you're basically producing less landfill gas for the same amount of space. That's where, that's kind of why we've been going to these engine plants, is they're more flexible, as you can add or subtract engines to match your gas supply. Generating electricity is really just a way for us to deal with the byproduct. It's not our primary goal. So if we're diverting these wastes to another way, we just adjust our engineering systems to deal with the feedstock that we have. Any other questions? Yeah.
You'll probably get to this in a moment, but what are the advantages or disadvantages of this versus a more conventional bioreactor?
You mean like a...
So instead of putting it in the landfill, we're running it through a higher process, higher speed system, such as like a sewage treatment plant, when we optimize the digest paper.
Well, the advantage is, in order to use, like, say, a food waste digester, like the county's got a couple, and Madison's looking at adding one. You have to source separate all that stuff. So basically, you'd have to source separate your food wastes and stuff. The disadvantage of these quote digesters is that you have to keep your food source fairly clean. As in, if you have too many burps and changes in your feedstock, it's going to change your bacteria and change your balance in them. The landfill, basically, you can, without any separate processing, no separate collection, you just put everything in one big vessel and treat it in place. So it's just a simpler system, and it's actually more cost effective. The problem with a lot of these smaller digesters is the economics still aren't that good on them. So especially, someone mentioned that natural gas is so cheap. Well, the cheap natural gas is also keeping your electricity rates cheap. So, whole economics on like a food waste digester is producing electricity. Well, when you got cheap electricity, it's kind of hard to cover your costs. So, the landfill is, from a cost standpoint, is a cheaper option.
So my background is an economist rather than an engineer, so if I can give an economist answer. Society has to put about, to do one of those kind of high value, turning it into ethanol or butanol or things like that, society has to put about 4 times as much resources into the process. It costs about 4 times as much. So the product at the end of it has to be massively more valuable to make it today with today's technologies and environmentally sound decision to do that. We believe as a company that trying all these technologies and running pilots makes a whole lot of sense, because eventually we'll find technologies which are better for the environment than what we're doing today, but we're not there yet. That helps.
Yeah. Do you guys do any communication on the product side with telling companies about who create the products that go into these landfills, about what chemistries and things are eventually better for you guys to make this more economical society as a whole? Like a full cycle type situation.
Yeah, we have a whole department on sustainability in the company, and then we also work with these companies for waste reduction. Like I said, we do the entire spectrum. So, landfills is kind of the end of the line, but we also have a whole bunch of source separation, and like I said, recycling is becoming our bread and butter these days.
So just an example of something we do, it's not so much on the manufacturing side, but when we work with universities, one of the major parts of the university we want to work with is the purchasing department, because there are gigantic opportunities to mandate how your suppliers send things to you, so that you don't have to find some way of using it afterwards. Gigantic opportunities to reduce packaging, and something just, for you guys to think about. You're a major, as a university system, you're a large customer for a lot of people, and large enough to mandate how your computers come to you, or how the white goods that are used on campus come to you. And that's a substantial way that as an institution you could reduce your waste, is it purchasing it before it ever comes on campus, change the way you buy it. And we do a lot of work on that.
It's again a management question. Are you limited to only America, or you work international? You willing to work international?
So we run landfills and waste hauling operations in the United States and Canada. Our waste to energy plants include, let me think, we've got one in the UK where I'm from. We have a joint venture in Hong Kong and several in the Republic of China. So it's mainly US and Canada in terms of our truck fleet. Our sustainability services, our consulting part of our company that will do the sort of thing we were just talking about, that will say work with purchasing departments. They'd go a little further field, but we're primarily a US company. We're the largest company in the waste industry. Waste industry is about 2% of GDP. So about $1.50 in the United States is spent on trash or recycling.
Are you looking at technologies to, I know like the landfills the gas will come off and you won't have any more gas. Are you looking to open up those landfills in the future to maybe get some of the metals, or if something comes to market that's valuable?
Believe it or not, we've actually looked into mining landfills, and we actually went out and dug test pits at a bunch of sites and actually looked at what's in there. In Wisconsin, believe it or not, we're doing a pretty darn good job, and most everything of value is out. In other words, you're not finding a lot of metals. The amount of wood waste you're finding in there is scattered. It's not like in recoverable quantities. So in certain markets, it might make sense to mine them. In Wisconsin, where we've had recycling programs for years and years, we really aren't finding anything of value to mine out of it. Yeah.
How long does it take for, so you said a landfill can be about 175 acres, 100, 200 feet deep. How long does it take to fill that up? So how often do you guys have to make it?
The thing you gotta remember on landfill, like I said, it's like building a pyramid. You gotta build the lower pieces first and go up. We only build enough liner for about 12 to 18 months of airspace at a time. So in other words, it's very expensive to build liner. It's like $250,000 an acre to put your landfill liner system in. So they'll put in, small pieces at a time, every year, every other year, and fill it, and then you keep working your way up the pyramid. You fill it up and cap it as you go. So you say it's a 117 acre landfill. We don't build 117 acres. You build, 3 to 10 acres at a time, and then fill that spot up, and then keep building new liner. So it's just kind of a perpetual construction project. Any other question? Yeah.
I mean, I was just curious, for a landfill of that size, you'd be dealing with hundreds of wells, and each well is connected to the other well. I guess I'm just sort of wondering, what form of automation do you have to control it, or is it just, somebody watching the dial?
Well, the plant's got a PLC that kind of control it. These power plants run 24/7. They're not manned 24/7, so they're fairly automated on there. The well field tuning, it's a minimum monthly, but if it's problem wells, you got to hit them weekly, daily, whatever. Like I mentioned, is like if you change one well, the way the power plant works, it runs on BTUs, so it's teaching so much power and energy. So if one well goes bad, it's pulling harder on all the other wells to get the same amount of energy. So that's why you have to keep an eye on your methane content, your oxygen content, because you can actually pull too hard, which pulls oxygen into the system. So you really just have to keep watching. Every day they're looking at the methane quality. It normally doesn't go south that fast, but within a day. So as long as you're daily watching it and tuning it and adjusting it, you're okay. Yes.
You mentioned how wet or dry the content is, and it affects the amount of gas that you can take between 2 years and 20 years. Is the amount of gas in that first 2-year period that you take and it dries up similar to the 20-year length if it's a dry site?
Typically, first up to 2 years, as the gas is going, starting to generate, quality is not as good. You got a lot more carbon dioxide in it, your methane's lower. So, a lot of times you got to mix it with higher quality gas. And then the same thing happens as the wells start to die. the methane quality drops and you get more of the inerts in them. So you know, from both ends of the curve, it's not as good a gas. You know, the middle of the curve is basically your best gas. Yeah.
How did you both get into waste and recycling and waste management? What interests you?
Basically, when I went to UW here, my advisor was Professor Ham, who was in charge of the solid waste program. And he basically said, "I want you to try my class." And it's actually been, you know, a very interesting career as an engineer because you deal with so many different things. You know, biology, chemistry, you've got, you know, from an engineering standpoint, you're dealing with electrical engineering, mechanical engineering, civil engineering, environmental engineering. You know. So there's a huge spectrum of different parts of the engineering world and science world. So it's fairly interesting. It's not like you're stuck making widgets all day long. It's something different. So, you know, from my standpoint, it's been an interesting career. You know, and I deal with hauling companies. I deal with transfer stations. I deal with recycling facilities. I do like half the state of Wisconsin, so I travel a fair amount. So I'm doing something different all the time. So, and it's the waste industry is a highly regulated industry. As in, you know, you have to be very diligent and very organized because of all the different requirements that you have to follow, which are constantly changing. But it's, you know, for me, it's been an interesting career.
I was an entrepreneur. I was a partner in a consulting company that helped businesses become more green. And when we sold that, it's good business, but when we sold it about 5 years ago, the bit of what I did I liked most was on the waste and recycling, waste diversion side. So waste management at that stage had kind of started where we are today, what we call our transformation, which is turning from a company which primarily handles trash into one which tries to figure out the most sustainable way to extract value. And when I was offered a job to do that with large universities and hospitals, I thought it sounded like fun, and it is. So, yeah, as I got out of consultancy and into business development in the waste industry.
More questions?
Thanks for that. We'd also like to thank Michelle Grindle for helping set that up and have these two awesome speakers come and talk. Right now we're going to take a quick break and then we're going to do a prize giveaway at 9:45. So make sure to be back here. We're having a Mortensen panel, and the break will be right over here. So make sure to look at posters, vote for posters, and I'll see you in a little bit.